Hello friends, myself Dr. Vadev Shaw. Okay, today we'll discuss about the characteristics of DC motor. Already we discussed about the torque equation. That is very important, I told. Okay, initially I will start from the torque equation only, then we can derive for the characteristic of DC motor at both shunt motor and series motor. Okay, then first come to the side. Before going to understand about the characteristic of DC motor, then initially we have to understand what are the characteristics are possible. The first characteristics you can see if I will write here the characteristics of DC motor, characteristics of DC. Then when I am talking about this characteristic of DC motor, there is two types. We can say that each one electrical characteristic as well as mechanical. That electrical as well as here we can say that is your mechanical characteristic. Then when we are talking about the electrical characteristics, then you can say that is also two types. One is your speed versus your current. Another one is your torque versus your current. You see, there is two components. One is your speed, another one is your torque. These two components are compared with the armature current. Then it is nothing but your known as your electrical characteristics. Okay. Similarly, when we are talking about the mechanical characteristics, that is the characteristics we can say that is the torque versus your speed, the characteristic. But when we are plotting this torque versus speed, there is three conditions we have to mm, identify. One is your constant speed drive. Another one is your, you can say, that is constant power drive. And third one is your adjustable power. Okay. And these three conditions can possible uh, in DC shunt. Then we go for the first case, that is your DC shunt motor. Then we will discuss about the series motor. But when we can say that characteristic of DC motor, then you see here there is two important factor we have to observe, that is one electrical, another one is your mechanical. Electrical is nothing but speed versus IA and torque versus IA current. And in mechanical characteristics, when we are obtained, that is in between the torque versus speed. Now, specific DC, or you can write here sound DC motor, right? Now come to the point sound DC motor. Okay, in this sound DC motor, we already know about the torque relationship with the uh, current. We already that is your torque. One formula we derived that torque is equal to 0.159 P by Z I by A. And one formula we derived from here. Another formula also we derived in that day, that in the torque formula, that is your torque equal to 9.8, that is your EB into I divided by N. And here I means that is your armature current. You can say in place of I means that is your armature current. Now from this, first we'll derive one condition, that is your, we can say, uh, torque versus speed. Okay, that is electrical characteristics we. And from this electrical characteristics, first condition we will observe torque versus speed. Sorry, torque versus armature current. Right? Then when we are talking about the torque versus IA, then we first find out the relation. And you see the first equation, what I have written. Torque equal to 0.159. This is a constant. Whole number always in the system. Or if you are already making a DC shunt motor, then definitely the pole is also constant. And what the Z also constant, because once it is designed means you can change. Another one is number of parallel path is also constant. And what are the variables? You can see that is flux and I. From this equation, we can say one term we are getting, that is your torque is directly proportional to flux and armature, right? If you are making in shunt motor, we know that this is shunt motor, flux equal to your constant. If flux equal to constant, then can I say torque is directly proportional to your I. From this you can draw characteristic graph. How you can draw the characteristic graph? You see, there is the, when I draw the characteristic graph, I will put the torque in y-axis and I will put the current in x-axis. Then you see directly proportional means, now you see, suppose I will increase this armature current, then torque is directly increased. Okay, and if this is your, you can say IA max, then this is your torque max. Then if I will plot the graph, then what will happen? Then one line will come like this. Okay, one line will come like this, and this is nothing but torque versus armature current characteristics. Similarly, we have to calculate the second one, that is your speed versus your armature current. When I am talking about this speed versus armature current, which formula we have to consider? We know, everybody know the back EMF formula. Back EMF formula is EB equal to, it is, P phi NZ by 60A. Now from this you can derive. You see, again the same term is coming. Like if I will mark this pole is constant, your Z is constant, A is constant, 60 is constant. Then from this you can write EB is directly proportional to your flux into speed, right? And from this you can derive easily the relation, uh, that is your speed versus Ia, means N is directly proportional to here EB by phi, right? If N is directly proportional to EB and inversely proportional to phi, then we can derive the relation, that is your EB. EB is what? EB is your back EMF, right? That N, uh, we obtain that N is directly proportional to EB and inversely proportional to phi. If N is directly proportional to EB and inversely proportional to phi, then what will happen? First find out the EB value in the shunt motor. When I am talking about the shunt motor, one thing you keep in mind that if I design, then armature resistance is there. And due to the armature resistance, what will happen? This is the armature, and here that is your field resistance. If you see this one, this is the voltage, right? Now, if you see here that voltage and armature resistance, that current will be like this, IL, that is is your IA and ISH. Only you consider this circuit, can say only consider this one, this loop. Then what you will get, that the equation, that is your V minus IA into RA minus EB, because this is your back EB, right? If we will see here that equal to 0, then immediately we are getting the equation that EB equal to V minus IA into RA, right? Now you put this equation in this, then what you will get, that N is directly proportional to V minus IA into RA divided by your phi. And in shunt motor, we know that flux is equal to constant. Then what you will do, that N is directly proportional to V minus IA into RA, right? And from this formula, we will draw the characteristics. That is your characteristic when I will draw. Then in x-axis, you have to put the current, and y-axis, what you will put? You will put the speed and current. Now you see the graph. Now you see IA suppose start from 0. This is the 0, and here IA is the maximum. Then if IA value is 0, then N is directly proportional to voltage. Then if your voltage is rated, then speed also rated. Okay, at 0 condition. Means when the armature current is 0, the speed is maximum. You can say N maximum due to proportional to voltage. When IA equal to maximum, then the drop will be maximum, and what will happen? Your speed also minimum. Okay, because you see that if that is N is directly proportional to V minus IA maximum and RA, then if IA maximum is there, then the drop will be also maximum, and the voltage value will be reduced. Then if voltage value is reduced, then speed also reduced. Then initial condition, if you will see, this is your N is directly proportional to voltage, and in this condition, what will happen when you are at the IA max? Then your speed gradually decreases due to the it is directly proportional to voltage. Now you see what we can say here, N is directly proportional to V minimum because it is V rated. Then you can see with the increase of the current, the drop will increase, by which what will the speed will decrease. Then we can say what is the decrease of speed, that is depend upon that IARA, this condition. This is all about your electrical characteristics. Now come to the mechanical characteristics, and in shunt motor, when I am talking about the mechanical characteristics, that you have to understand the what are the mechanical characteristics you can do. The next here you see, when I'm talking about the mechanical characteristics, then the curve between torque versus speed, right? This is the graph we have to plot when mechanical characteristic. But in this case, in shunt motor, what is the, that is the adjustable power drive you have to understand. That is, one is your torque versus speed will perform, and one is your torque versus speed when we will perform, that is your constant speed drive. Another one is your constant power drive, and here that is the adjustable power. The three conditions we have to see. First, we write the formula. Constant, what is the formula? Torque versus speed. In the torque formula, we derived one equation, torque equal to 9.8 into EP into IA okay, by N. If you will see the final formula, we derived in the torque equation, then you can say that EB into IA is nothing but the power. Okay, and I write from this equation that is torque into speed equal to 9.8 into uh, P out, right? Then in simple way, if you will represent torque and speed directly proportional to power. First, we see the constant speed drive. Here, the constant speed drive means again we will draw the graph. That is, one is your speed, another one is your torque. Constant speed drive means it is independent about the torque. Okay, and if you want the constant speed drive, what will happen? The constant speed drive is like that any value of the torque, what will happen? You are getting the constant speed. Because you see, if you see the equation, the torque and speed directly proportional to the power, right? If your power is you are making the constant, then what will happen? The speed will become the constant. Second, the condition that is your constant power drive. If I am saying here constant power drive, then what will happen? Then the torque and speed is directly proportional to the one constant. Then you can find out the relation that n, suppose speed is inversely proportional to the torque, right? Then if I will draw the graph of these two, then you see here, this is your the suppose speed, this is your torque, then what will happen? If when the torque will be decreased, your speed will be increased. And when the torque will be increased, then speed will be decreased. It is inversely proportional. Then suppose at torque zero value, what you are getting? Speed is very high in this point. But what happens when torque is maximum? Your speed will be minimum. It is inversely proportional. The graph will be like this. Okay. And you can say at this condition your speed is very high, but when in this condition your speed is very low, due to this relation. Third point, we will do the adjustable power drive. In adjustable power drive, what we can do, that is your first you see in adjustable power drive, that is two conditions. One is your, you can put here, that is suppose torque. This is your speed and power. You can see. Okay. Now, in adjustable power drive, we divide this condition into two parts. One is your, you can say that constant speed, variable power. Okay. And what will happen here? Constant power, variable speed. Okay. Now, first condition we will derive constant speed, variable power. You see, in this equation only, if I will make this one is constant, then a torque and power is variable. The torque is directly proportional to power. Then first make it constant speed. This is the constant speed. Then what will happen? The power will be variable. Understand my point? You see, with the vary of this torque, what will happen? The power will be also gradually vary. But if you will make the constant speed, now come to the point constant power. Now you make this one is constant. If you make this one is constant, then what will happen? Here we obtain that speed is inversely proportional to the torque. That means your graph will be the like this one, constant power drive. Okay, and your power will be constant. This is the graph. Okay, that is you can put here constant speed n equal to constant and here n equal to variable, here p equal to variable, and p equal to constant. These are the conditions you can see that was one is constant speed drive, constant power drive, and it is adjustable power drive which is possible across the DC shunt motor. Okay, these are all about your shunt motor. Now come to the characteristics of a DC series motor we'll understand. Because similarly to the shunt motor, series motor also the having the same thing we have to derive. First, again we will understand this relation. Already we derived that torque is directly proportional to flux into I, right? If torque is directly proportional to the flux into I, first we see that in shunt motor flux equal to your constant we have kept. But what will happen when we are discussing about the series motor, then one relation is there that we can put this is your equation 1, because otherwise you will confuse. Right? This is your equation 1. And in series motor, that flux is directly proportional to the armature current. If this is your equation 2, now you can see if your flux is directly proportional to the armature current, can I say that that is another equation you can derive, torque is directly proportional to your Ia square, right? Then torque is directly proportional to Ia square, then you see it is the one equation, this is equal to, you can say that y equal to mx square plus c. One, this is this type of equation. And if we will plot the graph of this two, torque versus speed, sorry, torque versus current, that is you can write here characteristics, electrical characteristics, then a relation between the torque and Ia, torque, right? Now you see torque is directly proportional to Ia square, and this equation, there is equation of a parabola. You see, when I will increase the torque value, then it is proportionately increase. That means it will initially it will come like the curve like this. Okay, we can say that a torque is directly proportional to your Ia square. Okay, but what will happen after reaching the maximum? Okay, after reaching the maximum, when you are further increase the current also, the torque value will be not like this. Then what will happen? Then again it will go to the constant. Means initially it will like proportionately it will increase, but after some time what will happen? Again it will not increase, it will be a constant. Okay, because it is the saturation time. If you are increasing the torque, what will current will proportionately it will increase. Okay, I square. But what will happen after some time? If you again increase the torque also, then the current will not increase because the capacity is already achieved. Ia is in saturation. We cannot again increase this one. That's why it will be like this after saturation, torque equal to your armature current only. Right? Now come to the next characteristics, that is your, we can say that another characteristic, that is your speed versus your current. Then when we are talking about the speed versus current, first you find out the equation, then we know the equation Eb is directly proportional to n phi, then here n is directly proportional to Eb by phi, and here we know that n is directly proportional to V minus Ia into Ra by phi. Okay, but what will happen when we are thinking about this one? Suppose we are making this n if V value is constant or V minus IA array value is constant, then what will happen? 1 by, because we are only focusing on the speed and the current, and here the speed, you can say the speed is directly proportional to 1 by IA, because you see here the flux value is there, then flux is directly proportional to the current, then N is directly proportional to the, sorry, indirectly proportional to the I. Okay. Now we see the speed versus IA curve. When I will plot the graph, then speed is here and IA is here, speed in y-axis, and I is here. Then if I will plot the graph, what will it is inversely proportional to, means what will happen? The graph will be like this. Means at 0 or minimum value of the current, IA minimum, you are getting the maximum speed. But when you are getting the IA maximum, you are getting the N equal to minimum. You are getting like this. Okay. This is all about your 1, 2, and 2. Okay. Now come to the point again. We will go to understand the torque. Now we will discuss about the mechanical characteristic of DC series motor. Then when I am talking about the mechanical characteristics, same equation we can start. That mechanical characteristic we can see here. Uh, that is the speed versus your torque, the characteristic. Then how to find out this relation? Then you see here, already we derived one formula, that is your N is inversely proportional to the flux, right? Then from this, in your series circuit, we another formula we derived, N is directly proportional, indirectly proportional to the flux, means the flux is directly proportional to the armature current. Then it is nothing but 1 by your IA, right? If your speed is like this, N is directly inversely proportional to IA, then what we derived in the first equation, that torque is directly proportional to phi into IA. And if see here from this, you can write here torque is directly proportional to your IA square. If torque is directly proportional to IA square, in place of this IA, can I write that IA directly proportional to the root over of T? Then in place of this, you can write N is inversely proportional to root over T. Then if there is a speed, there is a torque, then how to do that? You see here, speed is here and the torque is here. It is inversely proportional. Then the graph is same as the previous. Okay, that speed versus current. What is the graph? Speed versus torque is the same. This is the all about your shunt motor and the series motor. Compound motor, if you will start with the compound motor, then one thing you keep in mind, what are the differences? Compound motor circuit, only we are adding a series resistance to this shunt motor, and by combining both shunt and series, we are designing the compound motor, right? Then suppose, now come to the point, see the graph. I'm only drawing the graph here. First, shunt motor characteristic graph we will plotted. That is, one is your torque versus your armature current. What you develop that torque versus armature current, it is your linear, like this. For the shunt motor, here I am highlighting. This is for the shunt. Now come to the next. That is your series, for the series motor. What is the graph is coming? Initially it is looking like a parabola, but after the certain time it will come like this. After the saturation, what will happen? the armature here, the torque is directly proportional to the armature square, but after saturation, torque is directly proportional to the armature current. That is for the series motor. Okay, and we know that shunt motor plus series motor, that is equal to your compound motor, right? In compound motor, the graph a little bit improve. That is in between this graph. That is your compound motor graph. And see, they are also over compounding, under compounding, that is there. If this is your compound, then we can also plot the over compound. Over compound is like this, and under compound is like in between this. Like this is your, can say this is your over compound, and this is your under compound. Similarly, other glasses, other also we can draw. This is your torque versus current. Now come to the speed versus current. Then speed versus current. Now first point is if this is the speed. Initially, what we derived that speed will gradually decreases, right? But anyhow, the speed, if I will increase the current, speed also decreases in case of shunt. Okay. Now come to the in series motor, what will happen? It will sharply decreases like this. This is for series. Okay, you can say this is your series. Then if it is a series motor graph, then what will happen? Then you can plot for the compound motor. The graph will be like this is your improved graph. That is your compound motor. Then we can see over compound. This is your over compound, and this is your under compound. Okay, this is all about your graphs. Like similarly, you can also plot for the torque versus your speed. Torque versus your speed. That is approximately equal. We are getting torque versus speed graphs in both the cases. Then in short motor, that is different. Series motor, it is different. Okay. Then series motor is similar to like this we are getting, then it is all about your characteristics of the uh, DC motors. Now we'll conclude the summary of lesson number 5. That what we findings that DC motor characteristic describes the relationship between, you can see that is your speed, torque, and armature current. What we develop? Speed, torque, and armature current. You see, by considering these three units, we are deriving the characteristics. Okay, and the characteristics, key characteristics are the electrical characteristic, that is speed versus armature current, and torque versus armature current, where the armature current is the reference. Then come to the speed versus torque. This is nothing but your mechanical characteristic. Okay, Shunt motor have nearly constant speed with varying load, but we obtain that constant speed application. The shunt motor we are giving the constant speed because the relation is like this: torque Tn is directly proportional to P. Okay, and the second thing is that series motor exhibits high starting torque and vary at variable speed suitable for traction system. Okay, high starting torque. Why? Because we obtained one relation that a torque is directly proportional to Ia square. Okay, that's why the high starting torque in series motor we are getting, and we are it is only suitable. It is suitable for the traction system. Is electrical train, electrical drives we can use. Then compound motor is nothing but a combination of both shunt as well as series properties. Okay, by which what will happen, the characteristics is slightly improved, or slightly lies in between the Shunt series. Okay, we can say that is for the improvement or to compensate the armature reactions, or we can say the compensate the cross magnetic field, demagnetic field. We can use these compound motors, and how the characteristics will be improved. It is nothing but it is a combination of Shunt and series, and we are getting the desired output.